word Sudoku. So to solve this problem, we really need to know one concept, and that's sets. What sets are, sets is a data structure that stores only one of each element. So let's say I have a list containing 1, 1, 3, and 5, and we take the set of this list. Well, sets only contain one of each element, so we have duplicate ones, so in the final set, it's going to contain 1, 3, and 5. The duplicate gets removed, and we use this to our advantage when we solve this problem. So the logic here is that we want to be able to validate the validity of a Sudoku board, and criteria are each row has to contain one element from 1 to 9. The same goes for the column, and the same goes for sub 3 by 3 grids. So checking if a row has only 1 to 9, one of each, is very simple. And that's just a nested for loop. The same goes for the columns. What about the 3 by 3? Well, a 3 by 3 is defined by the upper leftmost corner, meaning if we know the position of this corner piece, then we can iterate through the rows and through the columns. So that's what we're going to do, right? When we isolate each of these upper leftmost points, we can define each 3 by 3 subgrid, and that's how we're going to process each grid in order to see if they only contain one of each element from 1 to 9. So let's translate this to Python. First step is to validate each row. So for B in board, we're going to initialize a set, right? What this is doing is that this accesses each row within the board, and for each board we get a new set, which is going to validate all the elements within it independent of the other rows. You can't put this outside the for loop like right here, because then it violates the logic of the elements in the other rows affecting the elements in a given row. So it has to be within the for loop right here. Now for I in range 0 to 9, the element is going to be b of I. And if that element is in the set, then we return false because it's not a unique element. Otherwise, it is a unique element which is represented by a string that's not the dot string. So therefore, we're going to add it to the set so that the element is no longer unique moving forward. And that's it. That's how we validate a row. And then we do the same thing for a column with one simple switch in the for loops. This for loop comes out, and this for loop goes in. The reason for this is because when we put the I in range 0 to 9 for loop outside, then it fixes the index for each row. And that's what a column is. A column is simply fixing the index for each row. So like the 0th column is where we take the 0th element of each of the 9 rows. So that's the logic. And now moving forward, we can now validate a 3 by 3 subgrid. How do we do that? Well, a 3 by 3 3 by 3 subgrid is defined by the upper leftmost point. So let's call it start point, and it's going to be an array storing all of these points. So for the very first subgrid, it's going to be the upper left one, and that's going to start at row 0 and column 0. And for the next one, which is going to be the 3 by 3 right next to it, it's going to start at row 0, column 3. And the same goes for the next one, 0, 6, and we see the pattern. 3, 0, 3, 3, 3, 6, 6, 0, 6, 3, and then 6, 6. Right? That's going to give us all of the starting rows and columns for each subgrid. Now we can access it by doing a for I, j in start point, right? It's going to access all the x and y coordinates within the tuples right here. And for I, or for row, in range of I to I plus 3. And then we do for column in range j plus 3. Because remember, I denotes the starting row, j denotes the starting column, and we plus 3 because each subgrid is a 3 by 3 grid with 3 rows and 3 columns. We're going to say we got to declare a new set right here if this element is going to be the board at the current row and the current column. If element is in the set, then obviously we return false, and otherwise if it's not a empty position, as denoted by a string that's not the dot string, we are going to add it to the set so that it's no longer unique moving forward. And that's it. We simply return true if all these cases pass, and we're good to go. So let's run it. And it passes, so let's submit. And there we go. It passes everything, and that's the solution.